Let's just do a little bit of basic Python together. Missings. Missings are thoroughly confusing. There are two basic ways of representing a missing that you might come across. Firstly, in the basic Python, even before you add NumPy or anything like that, there is a non-object. There's only one of them. It's a built-in constant, and it represents the absence of a value. So let's type a equals crikey, what was that? Let's type a equals none. What does that do? Well, none is a constant. It's in your computer's memory somewhere. And now a, the name a, points to the variable none. What is the type of a? Well, guess what? It's the none type. Now let's type b equals none as well. Now b is going to point, b is a name, and it's going to point to the exact place in memory where a is pointing, because they're both pointing to the one and only none object. Now, is a equal to b? Yes, it is. Is a actually the same object as b? So a is b means that a and b are both pointing to the same object in memory. Yes, they are. Now, none is an object, and pandas series have certain data types. They have loads of data types to do with numbers, but if something is not a number, if it's an object, then it will need to store the whole series as an object. But I think we're going to be lucky if we try putting none into this series. It won't upcast the whole series to an object. It will actually change the none to a NumPy nan, which we shall soon see in a minute, is in fact a float. So there you are, it's changed it to a float. If we actually look at this pandas series at index 3, we have a nan. So it's actually changed the none to a nan. They are very different things. Now, np_nan, which we were just talking about, is a special floating point value defined according to a certain international standard called IEEE 754. And this special floating point thing represents not a number. I find it very confusing. I suggest you have a look at the Towards Data Science Com blog that I've put there. So now, imagine we say that a equals np_nan, b equals np_nan. A is b means that a and b point to the same thing in memory. That's highly amusing. I wasn't expecting that. Let's try again. Is a the same as b? If you did that in R, you would also get false, that's for sure. Because if you don't know what two things are, you try to make them equal, you try to see whether they are equal to each other. We can't possibly know whether they're equal to each other or not. Now, more confusing stuff. Iterables and iterators. Once again, you don't need to listen to me talk about this. Have a look online at the original Python tutorial. Maybe have a look at these two things. But let's just try and see what goes on here. A equals range 5. Now, in Python, an iterable is anything you can potentially iterate over. Let's have a look. Can we iterate over this range? For thing in a print thing. Yes, we can iterate over this thing. So we have put our iterable into a loop, and it's done the trick. Now, it's not so easy to iterate over something. You need to keep track of where you are. You need to stop. Look, it stopped when it got to the end. It didn't go round again, for example. Python does this by creating an iterator from the iterable using the iter function. So we know that a is our iterable. So this is an iterable, but the for loop is going to create an iterator from our iterable by using the iter function. Let's do that ourselves. Let's create an iterator using the iter function. We've done that. Now, one of the things about an iterator is that it has a state. It knows where it's up to, and we can advance it by using the next method. So let's now advance it to the first one, to the second one, to the third one, to the fourth one. And what happens when we advance it now? Boom, it's gone. It can't go any further. That is because the iterator knew what its state was, and it knew when it got to the end of as far as it could get. But the original range is an iterable. When the for loop needs to iterate over it, what it does is it changes the iterable into an iterator, which can keep track of where it's up to. Zip. When you pass things to zip, it creates a zip object that pairs the first item of each thing together. The zip object is an iterator. That means, for example, as we've seen before, it has a state. It knows where it's up to. You can go through it once and then you're done. Let's create a few ranges, and we'll create a zip object. So here we go. For thing in zipped, print thing. What did zip actually do? I'm not sure if I mentioned that. It will take the first of A and the first of B and the first of C, which happen to be all ones. It will put them all together in a tuple. It will then take the second one of each and put them in a tuple. So you should get 1, 1, 1, and then 2, 2, 2. I hope so. Phew, that was lucky. Here you go. You can see there's the first tuple it's created. There's the second one. What's going to happen when I do this? Can you guess? Nothing is going to happen when I do that, because zipped was an iterator. An iterator has a state. The state it was left with at the end of here, the first time we did it, was the end. There wasn't anywhere else to go, so it didn't do anything. Zipped is not an iterable, it's an iterator. As we said, it's got the next property. It returns its contents one at a time. If you call next when you get to the end, that's it. Let's create it again. And you can see we can go through it one at a time, and just to do what we did last time, when you get to the end, boom. Now, let's talk about the unpack operator. Well, it unpacks arguments passed to a function. That's the range iterable, which we created before. If we create a zipped object out of these three things and we go through this, we force the zipped object to go through each thing by turning it into a list, we get what we expect. Now, can we call zip on the zipped object to try and unzip it? Ooh, no, you can't. You can't. That's really horrible. It's a gibongous mess. If you want to try and call zip on there to try and unzip it so you get 0, 1, 2, 3, 4. If you want to do that, you have to unpack these tuples before you pass them back into zipped. The way to unpack an object, or to unpack an argument, is very simple. You put a star in front of it. So he says, hoping, everything's gone wrong tonight, but I'm hoping that that will do the trick. Yay, I didn't do the trick. I think that is because I didn't recreate the zipped object, so there was nothing to go over because it reached the end. Yes, it's unpacked it into A1. A1 hopefully has now got the range in it again. Indeed it has. 0, 1, 2, 3, 4. The last thing I wanted to mention was dictionaries. We've used dictionaries, so I'm sure you know them, but I just want to say it in any case. We create a dictionary with curly brackets. Dictionaries are created from key value pairs. Just like a dictionary, it has the word that you're interested in and then the information about what the word means. Likewise over here, we have a key, which is the equivalent to the word, and like the value which goes with the key. If you want to then, after creating the dictionary, you want to know what value is represented by the key col1. There you have it. And the final thing, useful thing we can do with dicts is to create data frames. There we go. That's all I wanted to say about the Python basics for the moment. We're now going to move on to H2O.